students. So those who have not subscribed my channel, please subscribe my channel and also share my videos. So let us start with another topic, resistors in parallel of chapter 12 electricity, class 10 CBSE NCERT. So the resistors here are connected in parallel. Now how can you say the resistors are connected in parallel? If we connect the starting end of all the resistors to one point and the finish end to another point, then the arrangement is said to be in parallel arrangement, and the connection, whole connection, is said to be parallel connection. Okay, so for understanding the parallel concept, the connection concept of parallel connection, another activity is being given in the NCERT book. Let us recall that activity. So in this activity, again they have taken a battery, a key, ammeter and the three resistors. So we will be dealing with the ammeter and voltmeter, and we will be checking how the ammeter reading changes, how the voltmeter reading changes when the resistors are connected in parallel. Okay, so here first of all a connection is being made, a battery is being placed over here, and key is switched on. As soon as the key is switched on, the current starts flowing in the circuit and the ammeter reading is being noted down, and the ammeter reading is being noted down. So let the ammeter reading be I amperes. Let the ammeter reading be I amperes. Okay. Okay, so now connect a voltmeter across the points X and Y. Connect a voltmeter across the points X and Y. So let us connect a voltmeter over here. Okay, and note down the reading of the voltmeter as well. So let the reading for the voltmeter be V volts. Okay. So these are the readings when the resistors are connected in parallel, and we are taking the equivalent, all the resistance throughout the circuit, and across those equivalent resistor across the circuit, the potential difference is being measured. Potential differences reading is being taken for the potential difference across the points X and Y, where all the three are being in the picture. Okay, so voltmeter reading is being taken and it is equal to V volts, and also the current is also for the whole circuit when the resistors are connected in parallel. Okay, now when this thing is done, switch off the key and the connection is being broken down. Then remove the ammeter from here and connect it across one of the resistors connected between M and this point Y. Okay, connect the ammeter between there, and also remove the voltmeter from here and connect it between L and M across the resistor R1. So we want the potential difference across the resistor, only the resistor R1, and also we want the current to be flowing across the resistor R1. So we see that we conclude that when again the key is not shown over here, I'll just make a key over here in the circuit. So when the key is being again switched on, we plug on the key and key is switched on, the current starts flowing in the circuit, and what we see that the voltmeter reading remains the same as V volts across the resistor R1, Here we have taken 3 resistors. You can also take more than 3 resistors, n resistors. 3, 4, 5, any of the quantity of the resistors you can take, and you can deal with the concept over here. Okay. So here we see the voltmeter reading remains the same, but the current reading changes. Here the current was I amperes, and here the reading is changed and it came out to be I1. It came out to be I1 over here. Okay. Came out to be I1 over here. Okay. Then, but the voltmeter reading across R1 is V only. So let us write down the across R1 is V, but ammeter reading is I1, V1 volts. Okay, is V1 volts, but across ammeter reading across R1 is I1. Then remove the voltmeter from there and remove again. First of all, after taking the readings, switch off the key, and then remove the voltmeter from there and ammeter from there as well, and then connect it across the resistor R2. Okay, remove from there and connect across R2. Okay, connect it across R2. So we again plug on the switch, we switch on the key, and we again see that the voltmeter reading is again V volts only. So the voltmeter is being constant and the ammeter reading changes, and the current is also current reading is changed, and it came out to be, let us say, to be I2. Okay, so across R2 the voltmeter reading is V volts. Okay, is V volts, but ammeter reading is I2 amperes. Then switch off the key again, and now remove the voltmeter from there and put across the points S and T. Put across the point S and T. Also connect ammeter in series with the R3 resistor. So now this time also we note that the voltmeter reading remains the same, which was V volts, which we have measured earlier when all of the three were taken in combined form. Okay, the V volts. So the across R3 also the voltmeter reading was same as V volts, but the current changes and the current reading changes, and suppose let us say it to be I2. So across R3 also is V volts, but ammeter reading is I3 amperes. Okay, so, and we also observed one thing to be noticeable, that the current I1 plus I2 plus I3 was equal to the current I amperes. all the sum of all the individual currents when the reading of ammeter was taken, when we have taken the individual resistances R1, R2, R3 across them. So when in series with the R1 and R2 and R3, so the sum of all the currents was equal to that current which we obtained when we were taking all the combined resistance. Okay, when we were taking across in series with the combined resistance, when we have attached a ammeter over here, then we were getting the value I, and that I value is equal to I1 plus I2 plus I3. So the result which we were getting over here was equal to I1 plus I2 plus I3. Okay, so we already know that from Ohm's law, by Ohm's law, V is directly proportional to I, V is equals to IR, and I is equals to V upon R. Okay, and I is equals to V upon R. Okay, so for I1 the value will be equal to V upon R1, because I is the current when the ammeter is connected in series with R1. So for the resistor R1, the voltage is same V, but I1 changes. So for that, I1 will be equal to V upon R1. I1 will be equal to V upon R1. Similarly, I2 will be equal to V upon R2, and I3 will be equal to V upon R3. In all the three cases, the V potential difference across the resistors was constant, that was equal to the V volts only, that was equal to V volts which we have calculated when we were taking the resistor across X and Y. So the potential difference across X and Y is equal to the potential difference across LM, PQ and ST. So potential difference remains constant when the resistors are taken in parallel, are connected in parallel. Okay, so from here I1, I2, I3 we have got the values. Let us put down the values. Okay, and for I the value will be equal to V upon R. R is we can take the RP. RP is the equivalent resistor of the parallel connection. Okay, so let us put down V upon RP is equal to V upon R1 plus V upon R2 plus V upon R3 is equal to. So we can take the V common from here. We have taken common, so inside the bracket it is left 1 upon R1 plus 1 upon R2 plus 1 upon R3. Okay, so V gets cancelled, and ultimately we are left here with 1 upon RP is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. We are left here with 1 upon R1 plus 1 upon R2 plus 1 upon R3. So this is the formula for the equivalent resistance formula for the resistor when the resistors are connected in parallel. And this formula is very much important from the numericals point of view, because the numericals come when it is asked to find out the equivalent resistance value when the resistors are connected in parallel. So we have concluded to the formula that the reciprocal of the equivalent resistor is equal to the sum of the reciprocals of the individual resistors, is equal to the sum of the individual resistors. So we need to take the LCM over here and we need to reciprocate it. So my RP will be equal to R1, R2, R3 upon R1 plus R2 plus R3. Okay, so this will be the value of the equivalent resistance when the resistors are connected in parallel. When the resistance are connected in parallel, this will be the formula. So in this manner we need to solve for the numericals, because it is very much important from the numericals point of view.